Hello, welcome everyone. In this video, I'm going to go over a couple of properties of derivatives. The first one is called the power rule of derivatives, and the second one is the derivative of a constant times a function. So how do we do that? So let's take a look at the first property, where it says the power rule of derivatives. In this particular rule, if we have x raised to nth exponent, so x is if x is raised to some n power, where n is equal to a negative number, could be a positive number, could be a fraction, could be any of these, except n cannot be equal to 0. Okay, so it could be positive, any negative number could be -1, -2, or any number. It could be any positive number that you can think of. It could be a fraction, okay, 3/2. It could be a negative fraction, whatever you can think of. It could be any of these numbers except 0. And the reason it cannot be 0, because if we take a x to the 0th power is just equal to 1, which is constant, and the derivative of constant is 0. So we can apply the power rule here to x to the n expression, and when we simplify it, when we apply the power rule, d over dx of x to the n, n becomes the coefficient times x to the n minus 1. We subtract 1 from the exponent. And the second one is the derivative of a constant times a function. So if we have a c times f of x, we want to take the derivative of that. So d over dx of c times f of x, which c is a constant. We take the c out of the derivative, and we can take the derivative of function. Okay, so whenever there's a coefficient with your variable term, you can take it out of the derivative and then take the derivative of the variable or the function. So if we have c times x to the n, then we want to take the derivative of that. Okay, then we can take the c out, and we can take just the derivative of the x to the n. Okay, so we can take the coefficient term that is multiplying with our variable out of the derivative and take the derivative of the rest. Let's take a derivative of a few of these examples. We want to take the derivative of 3 x squared. Okay, now since 3 is a constant, multiplying with our variable, we can pull it out of the derivative. So d over dx of x squared. And now we can apply the power rule here. So we have 3 times, we bring the 2 times x to the 2 minus 1. So it would be 6 times x to the 1, which is 6x. So this would be the derivative of this function. Now let's do the same thing here. We want to take the derivative of 5 times x to the 4th. We pull out 5 from the derivative, so we write it as a coefficient or multiplying with the derivative. So it's 5 times d over dx of x to the 4th. And in the next step, we can take the derivative here of x to the 4th. So it's 4 times x to the 4 minus 1. So this is equal to 20 times x to the 3rd power. All right, let's do a few more examples. We have this 2x to the 4th raised to the 2nd power. So what I'm going to do is simplify this first. So we're going to take 2 to the 2nd power times x to the 4th to the 2nd power. So we have 4 times x to the 8. This is just properties of exponent. When we have exponent raised to an exponent, we just multiply the two exponents, and that would be the end result of the exponent term. So we have 2 to the 2 is 4, and x to the 4 to the Second power is 4x to the 8, x to the 8. So we have 4 times x to the 8 or 4x to the 8. And we take the derivative of that, d over dx of 4x to the 8. We can take 4 out of the derivative. And now we just take the derivative of the x to the 8. And this should be equal to just 4 times 8 times x to the 8 minus 1 and 32 x to the 7th. So I basically, when I took the derivative, I brought this 8 to the front right here times x to the 8 minus 1. So x to the 8 minus 1 is 7. So it's 32 x to the 7. And this one, we do the same thing here. We want to take the derivative of 5x to the 4. We take 5 out of the derivative term, so 5 times d over dx because it's constant, x to the 4. And now we have 5 times, we take the derivative of this x to the 4, so 4 becomes the coefficient times x to the 4 minus 1. So we have 20 times x to the 3, which is 20x to the 3. This is our final answer.